Hi modelers, it's Chris and welcome to the next video in the series of model railroad automation. Checking turnouts, points and blocks are not occupied before they're used. Now modelers, before I get into the code on this video, I've got to apologise for the delay in getting this video done. Unfortunately, as you know, I had a stroke and I'm not able to use my right hand and arm. So the left hand, I've joked a few times about, it's a bit of a slow learner, and this is one of those times. So a little bit more about that at the end of the video, so stay tuned for that. So now let's get into the coding and let me show you how you can test if a loco is in a certain block or a point. So now we're looking at the DCC-EX installer open, and you'll see that I've got a few more files up in the tab area. Basically we're going to be looking at blocks and turnouts. The other two tabs I'll draw your attention to is sequences test and autos test. Now I'm not going to be covering those two tabs in this video. Now the code will be posted in the community section on YouTube. So basically what we're trying to do is know where the loco is on the layout and give it the correct instructions to move forward. So what we can't do is send a loco into a section that has a block or a turnout already occupied. Under blocks, we've got all the blocks on my test track and we're checking to see if the block is occupied, and if it's not, we're going to move forward. The thing to consider is that you may have a number of blocks that you've got to test for in the section of track that you're going to go down. So the test track, although it's got 8 blocks, section is the entire group of those 8 blocks, so we have to test for each one. Now in actual fact we're testing for 7 because the loco is at one end, so that's the starting block, and obviously that's okay because the loco is there, so we're just going to test the 7 block. And the same thing goes for a turnout. If you're having a section of track coming out of a siding, going through a section that's got a bunch of blocks in it, and then going through another turnout into another passing siding, you have to look to see that all of those pieces of track are unoccupied before you send the loco forward. So now let's start with the blocks. And first of all, I'm going to introduce some extra lines in the code which will make it a little bit easier for you to read. We have a sequence, and the sequence number is CBO B7 to B1. In other words, it's going to test the block B7 to B1. At the beginning of that, we have a virtual pin that we need to set to false. If block 7 is occupied, then we set the V pin to true. We send a message to the screen, block 7 is occupied. We wait for 1 second and then we start again. We jump back up into the sequence, we reset the V pin, and we look at block 7, and if it's occupied, well, we just continue to cycle through this section. If it's not occupied, we then move on to the next block, block 6, and we go through the same process, setting the V pin true, sending a message to the screen that block 6 is occupied. We wait a second and then we follow through the same sequence, and we continue to do this looping process for each block in the section, and the process repeats itself for every block in this particular section. Once the block is clear, then bypasses this code and goes on to the sequence that's using it. So here we are calling the sequence to test the blocks, and once we've tested that all blocks are free, then continue with the sequence that started it. So drive loco, here's where we're calling the test, and then after we've completed that, we go on through setting the various points and testing those. So that's the process for checking the blocks in the forward direction. Look at the reverse direction. As you can see, we're calling the check block occupied B2 to B8 sequence, and that sequence is here. It's exactly the same as the forward sequence, however the blocks are reversed in order that we check them. So now let's move over to turnouts. Turnouts are fairly similar to block, except with blocks it's a sequence that we're addressing. In a turnout, it's a virtual turnout that runs the code. So the process is the same, that we look at a block, we say that the block is occupied. On my test track I'm using screen 1, position 5 and position 6. So that's because I have a group of turnouts. I'll get on to that in a minute. We do the same thing with a delay. Now the delay is there for the loco or whatever is occupying the turnout. Time to clear the turnout. And then we toggle the turnout number. So we've thrown it here, we've tested that it is thrown, and that's brought us into this section of checking whether the block is true or false. So when we go through this stage, we toggle the turnout, so we put it back to a closed state. We're not actually moving the point or turnout blades, we're just toggling to put the information on the screen that turnout number 5000 is closed in this case. Now a block of turnouts is similar to a sequence that has a series of blocks, and each turnout is a block in itself. So we're testing for 2 blocks in this example. So block number 3, if that is occupied, we come into this section and we skip back out of it and repeat the process like we did with the block. If this block is not occupied, we go else and we check the next block. Same thing, if that is not occupied, then we drop into the piece of code that's there to activate the points themselves, and the thrown instruction here changes the button title on your controller. There's a delay in this particular example because one of the turnouts has a delay in the middle of it. Is there for the relay to activate, which changes the polarity of the frog. Then we go on to setting the turnout so the buttons on your are updated. Then we finish the process of the second half of the movement. We notify the screen on both lines 6 and 7 that the turnout is now thrown. We do the same process on closed. We check the blocks that the turnout is in, and then we go through to the code if they're all empty. So let's do a quick recap. The first block we test to see if it's occupied, and if it is, we run through the code just below that. Now in that code there's a delay of 1 second, and it continues looping through that until such time as it becomes unoccupied, and then we move on to the next block. We test it, and if that is occupied, we then loop through that block until it becomes free for the loco to travel forward. And that's basically all you do. Doesn't matter how many blocks you've got. Could be only a couple, or it could be many times what I'm showing you. Now turnouts are essentially the same as block. It's the else part that's different. So we test for the block, we run through updating screens, we have a 1 second delay, we then toggle the turnout to make it, because that's the state the button was in at the time you pressed it, and we keep doing that and delaying 1 second, just the same as block, until it's clear, and then we go through the else statement. So that brings us to the end of another video. I hope you enjoyed it, and if you did, please subscribe and hit the like button. It'll help us grow. The next video is going to be entitled "Let's Squash Some Bugs in Your X-Rail Code." Okay, so this is one of those times where I'm feeling a little bit foolish. I spent ages trying to sort out that was one of those intermittent problems that come up, and I was blaming the software and all sorts of things, trying to work it out, because there was a change in the software at the time the problem started to occur. Now, what I did, and it was my fault, the little board on the screen at the moment is a 4-way connection board for the 2IC squared bus. Now, the way I connect them, I've got to, with the thumb and forefinger, I have to push it together. So I have to line up the plug, which is a little bit hard to do. I need to grab it on the top of the plug and the bottom and push them in till the plug seat, and that's what happened. It didn't go all the way in, so therefore when I was testing, trying to find out the fault, everywhere else I was getting positive readings when I used the multimeter, and I didn't go far enough back. So fiddling around, eventually unplugged them and plugged them back in, and guess what? Yep, it worked. So for me for not doing it properly in the first place. Anyway, in our next video we'll talk about how to solve those sort of problems and not leave them for a couple of weeks. Don't forget, if you need any help or want to make any suggestions for future videos, please post a comment and I'll get back to you as soon as I can if you're asking a question. Anyway, I'm Chris and this is Model Railway Automation with DCC-EX. Support the people who supported us. The supplier's web addresses will be listed below in the description.